Hey, Honors Chemistry. So I just wanted to send a reminder and helpful video on worksheets 2 and 3. From last we left off, we learned to balance and then eventually write and balance chemical equations. And we used particle diagrams. I'm going to use particle diagrams as the way to balance in here, but there are definitely other ways of doing that. So I'm just going to skip around and jump to a couple of different ones. So let's say on the very first part 1, I'll look at something like number 3, right? So I'll draw phosphorus as a shaded circle, P. I'll have Cl2 is 2 empty circles, and then PCl3 is something where phosphorus looks like this, and there are 3 Cl's. Okay, now I want to balance this chemical equation. That means I want the number of atoms on the left side to be equal to the number of atoms on the right side, not molecules. So I have 1 P over here, 1 P over here, I'm good. I have 2 Cl's over here, but 3 over here. I have too many on this side. I don't have enough on this side. I have to add another Cl. Now, the only way that I could add Cl's on this side is by adding a Cl2. And so, in doing that, now I have 4 Cl's on this side and 3 on this side. Now I need to add more Cl's to this side. So this is a game kind of going back and forth of, that's why it's called balancing. I add more, I take away. I can't take away. I add more until I have the same amount on both sides. So I have 4 on this side, I have 3 on this side. I have to add on this side to get more chlorines. My only way of getting chlorines on this side is by adding another PCl3. So now I have 6 chlorines on this side and 4 on this side. Well, I need to add another Cl2 and now I'll have 6 here. That's good. And notice how I just stuck with balancing chlorines, right? I wanted to make sure I had the same number of chlorines on both sides before I move on to looking at anything else. Now I'm going to move on to phosphorus. I have 2 P's, 1 P over here. Well, all I got to do is just add another P. And now I have 2 P's on this side. I have 1, 2, 3 Cl2s. All right, or I have 2 P's on this side, 1, 2, 3, 4, 5, 6 Cl's, 1, 2 P's, 1, 2, 3, 4, 5, 6 Cl's. That required 2 P's, 3 Cl2s, and I got 2 PCl3s. So, how are we balancing? So we want to make sure that we have the same number of atoms on both sides. So same number of atoms, not molecules, on both sides, and stick with one element before moving on to others. Before moving on to others. Notice how I did that with the Cl. I was just like, all right, let me focus on Cl. Oh, all my Cl's are good. Now I go to the P, and then I figured it out. All right, so let's do another one. Let's do something like, I'm going to jump down here to number 6. It says H2 plus SO2 gives me H2S and H2O. I'll represent H2 as small circles. I'll have S as like a colored circle. O will be a bigger circle. H2 are the small circle, S. So S, small circle. O, big circle. Little circles. Okay, so start by drawing all of the chemicals they gave me in the equation. Now remember, this is the left side, which is the reactants, and this is the product side, which is on the right side. I want the same number of atoms on both sides. Okay, so right now I'm looking and I see I have 2 H's, 4 H's here. 2 O's, 1 O, 1 S, 1 S. So I'm going to start with the first thing I said, H's. I have 2 H's here and 4 H's here. The only way for me to get the same number on both sides is if I add another H2 over here. Now I have 4 H's on this side, and I have 1, 2, 3, 4 H's on this side. So far, so good. I have 1 sulfur, I'm good. I have 2 oxygens and 1 oxygen. The only way for me to get more oxygens on this side is by adding H2O, and I have 2 over here and only 1 over here, so I gotta add another H2O. Remember, I can't just add oxygen by itself. Oxygen comes in the form of H2O. Oxygen is in H2O, so I had to add another H2O. Now I have 2 oxygens, 1 sulfur, And oh, now I have 1, 2, 3, 4, 5, 6 hydrogens. 1, 2, 3, 4 hydrogens. Well, I gotta add another H2. And it looks like I'm balanced now. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2 O's, 2 O's, 1 S, 1 S. That required 3 H2, 1 SO2, 1 H2S, 2 H2O. And now it is balanced. Okay, let me jump onto the back side of worksheet number 2 and show you how you could write balanced chemical equations, and then eventually that could turn into balancing them. All right, so let's look at a solution of hydrogen chloride is added to solid sodium bicarbonate, and they gave you in this problem sodium bicarbonate. Hydrogen chloride. Hydrogen is H plus 1. Chloride is Cl minus 1. Okay, if you wanted to write hydrogen chloride, H and Cl, they both have a plus 1 and minus 1 charge. I only need one of each. So hydrogen chloride would be HCl. So when a solution of hydrogen chloride, it's a solution, so that's going to mean aqueous, is added to solid sodium bicarbonate, the products are carbon dioxide, water, and aqueous sodium chloride. Carbon dioxide, carbon is C, dioxide means O2, right? That's the way that we write formulas for molecular compounds. If they have those prefixes in there, I just use the prefixes to tell me how many there are, and if there are no prefixes, I just say 1. Water is H2O. And then sodium chloride is Na plus 1, Cl minus 1. And so that would be NaCl, right? They both have plus 1, minus 1. The sum of the charges needs to equal 0. If you crisscross, I'll get NaCl. And now I know I wrote the charges here for hydrogen chloride. It's one of those special kind of, it's a molecular compound. It only doesn't give you any prefixes, so we could say that it's one of each. Later on, you'll see that it'll give you hydrogen chloride like in a later problem, and it tells you that it's HCl. I will give you hydrogen chloride is HCl, but if you didn't know that, both of them have charges of plus 1 and minus 1. If I did the crisscross method, I should get one of each. All right, and so now I can begin to write this. The solution of hydrogen chloride, HCl, aqueous, is added to solid sodium bicarbonate. They gave you that, but just in case they didn't, sodium is Na plus 1, bicarbonate is HCO3 minus 1. These were polyatomic ions, bicarbonate. If I do the crisscross method, I only need one of each, and that's where that came from. So sodium bicarbonate, bubbled, right, solid. The products are carbon dioxide, CO2, plus water, plus sodium chloride. Okay, now they didn't give you the states here, so it says aqueous sodium chloride, so I'll put AQ for aqueous. They didn't give you the states of water and carbon dioxide, but carbon dioxide is typically a gas. If you have future problems, I have to give you that it's a gas, but carbon dioxide is typically a gas, water is typically a liquid. All right, so now let me see if, now I'm going to go from writing the equation to balancing. Now, how did I know to put this over here? It says the products. That means they're to the right of the arrow. Right, so the products to the right of the arrow. All right, and so now I'm going to do H is little c, little a, little circle, big shaded circle for Cl, Na, and what I'll do for, so Na will be, let's say, a small shaded circle. H is this shaded circle. CO3, I'll make C an X, and I'll make the O's bigger circles. And then I have CO2, okay, so I have C is going to be an X. O's are the big circles. H2O, big circle with little circle. NaCl, little circle, like that and like that. Now in counting, I have 1 Cl, 1 Cl, good so far. 1 H, 1 H, 2 H, so good so far. 2 H's, right? So 1 H, 2 H, 1, 2 H is good. 1 C, 1 C, 1, 2, 3 O's, 1, 2, 3 O's. This is balanced. This just needs one of each. Okay, so I could put the 1 in front, but I don't need that. Okay, so this was just a helpful video for worksheet number 2. I'm going to post another video on worksheet number 3. If you are still struggling with this, there are longer videos that are in the Google Classroom and on the Remind from previous messages on how to do this explicitly. I'm going to send another reminder video in a little bit on worksheet number 3, which is all about writing and then balancing the chemical equation. Alrighty, hopefully you have success in completing worksheets number 2 and 3.